Volume of a pyramid. Take it away, Mr. Romanovich. Hey, that's me. Welcome back, of course. So today we're going to do volume of a pyramid. We just did volume of prisms. Here is a prism, you can see, and then here is a pyramid. Kind of flip it around here a little bit. And what you'll see here, and the difference is, this prism has two parallel bases, top and bottom here, or side to side, two parallel bases. This pyramid, though, only has one base. And then that pyramid is named by whatever base it is. So this would be a rectangular pyramid. This, of course, is a triangular prism because the base is a triangle. But we're going to be doing the volume of these types of shapes that have one base and no base on the top. It just comes to a point with the vertex. So by the end of this, you'll be able to find that volume in a pyramid and solve a problem like this. So pyramids, what we're talking about is just what I said. We're talking about one base, kind of my best shot at the drawing, okay? Sorry. Give me a break. So we have a base, right? And then each of these faces that comes off of one of the sides of the bases is called a lateral face. And then all of these lateral faces meet at one vertex. And that's this point right up here. We have a volume for finding this. The volume is similar to base times height, but instead what we're going to be doing is 1/3. That's a little loose. Volume will be 1/3 base times height. Maybe I'll rewrite this so you can see it a little clearer. Should have left myself a little more room. So the volume of a pyramid is 1/3 big B times H. And then that big B is the area of the base, whatever the base is. So for instance, the area of this rectangle would be the area of the base for this. If it was a triangular pyramid, it would be area of that triangle that's on the bottom. And then we know it's the base based on a vertical line that comes from the vertex of the shared lateral faces down to the base that forms a right angle. So if I were to drop a string with a weight, it would hang perfectly perpendicular to the base, and that determines our height. So we find the surface area of the base and then multiply it by the height and then multiply it by 1/3. Okay, let's try a problem. Let's see what we got here. Might make a little more sense if we get the numbers involved. So looking at this, we've got a triangular prism here, or a triangular pyramid here. And that's the first thing you're going to ask yourself. What kind of base is it? So what I know is it's a triangle. And then I want to find the area of that base. And I know my area formula for a triangle is 1/2 base times height. So my area for a triangle is 1/2 little b times h, big B being the base, the entire base. So I'll get my handy dandy and then I'm going to punch in 8.1. I've got a base there. I've got a height of 6.4. And then I multiply or divide that by 2 or multiply it by 0.5. And I get 25.92 meters squared. So that's the area of my base, my big B. Now for volume, what I'm looking for is 1/3 big B, so this is big B equals, times the height. And we see here our height is this imaginary line represented with the dashed line of 11 meters. So if I rewrite my equation here, I've got 1/3 times 25.92 times 11 meters. And if we punch that in, clear, 25.92 times 11 divided by 3, right? Because we're not doing 1/2, we're doing 1/3. Divided by 3, and that gives me 95.04 meters what? Is it squared? Are we thinking of a flat area? or cubed, how many little cubes could we fit in there? You're right, it's cubed. So we get 95.04 meters cubed. Now don't be overwhelmed by formulas. Formulas are really straightforward and easy to use, as long as you understand what you're figuring out for what. You know 1/3 is 1/3. And you know big B, this is what the key to this is, big B is the area of the base. It's not just one of these, but it's the area of that base on the bottom of the pyramid. And then H is the height, the distance from the base to the vertex that forms a right angle. So it's perpendicular. That's a future word for you. Let's try this one. And we saw a couple of these before. This is where we're going to get 3 of our 4 pieces, and then we have to solve for the remaining piece. What we see here is we see a triangle that has a base that's a rectangle, and that impacts how we figure out what big B is. So we know big B equals base times height, or length times width, or anything you want to call it, but these two that form a right angle here for our rectangle. So we know big B is going to end up equaling 45 inches squared. Right? Uh-oh, we don't have the height. But we have the volume. All right, let's see what we can do. We know our formula is volume equals 1/3 big B times H. So all we do is, and this is the best thing about formulas, we take the things that represent and then we implement what we know. We know this is big V right here, so we know that 90 equals 1/3 is 1/3. 1/3. Do we know the base? We know the base. The base is 45. Do we know the height? Ah, there we go. We don't know the height. So that leaves us just the variable H. So the first thing I would do is, if you want to, you can still do this. Draw the wall. I would solve some of this over here. So we've got 90 and 1/3 of 45. 1/3 of 45, or 45 divided by 3, is 15. So that'll leave us 90 equals 15H. And now you're going to hit this out of the ballpark because all of you have been nailing these equations. So if we have 15 times H equals 90, or 15H equals 90, if we see multiplication here, you know what we're going to do to undo it? We're going to divide by 15. And what we're going to end up here is 15 plus 15 is 30, and there are 3 30s at 90. So I'm thinking it's 6. 6 times 5 is 30, carried 3. Yep, 6. So we end up with 6 equals H, or H equals 6. What we look for then is, what are our units? Inches. So what we know is the height is 6 inches. And because it's height, it's not an area or a volume. It is a distance. There it is. Had to find it. It is a distance, so it's not squared or cubed. Okay, let's look at the target. I wrote it on a little smaller board. So here's our target. Yoink. We've got I'm not going to tell you what kind. We've got a pyramid here, and what we're seeing here is 2 values for the base as 3.2 inches and 1.4 inches. And then we're seeing a height of 2.8 inches, excuse my thumb. And you should be able to find the volume of this. Make sure you use that formula right there. Volume equals 1/3 big B times height. Okay, if you have any questions, be sure to ask me. Ask Miss Benoit. Check your book. Rewatch this video. Good luck.